My name is Samantha Benton, and I will be going over my presentation for chlorophyll-A at the near polar zones as well as similar data. This presentation provides information about the properties in the ocean on our polar arrays, between the properties of the water and how geography plays a big role. Chlorophyll-A is a big property that is needed for photosynthesis to happen. This presentation goes over how chlorophyll can differ in certain areas and how the temperature can change and affect how it prospers and works in those areas. The polar arrays are the Imminger Sea Array in the North Atlantic Ocean, the Station Papa Array in the North Pacific Ocean, and lastly the Southern Ocean Array, in the South Pacific Ocean, which is where this presentation will cover as we go on. The thermohaline circulation within the ocean plays a huge effect on how the temperatures in the water go up or down. With that will cause several different properties in the oceans to change, especially with the seasons and the times of years. Chlorophyll is a property that is used for photosynthesis. With that alone will cause the colder climates to have a much lower amount of algae and many other different organisms that may use photosynthesis to survive and eat. Properties within the oceans and different organisms within the ocean all rely on one another in one way or another. This presentation shows just a short snippet of how it all affects each other in the big grand scheme of things. There are many different places where scientists and tools are placed around the globe that monitor these different properties so that we all can study them and learn from them. For the introduction, I have here chlorophyll. The definition: chlorophyll allows plants, including algae, to photosynthesize, i.e., use sunlight to convert simple molecules into organic compounds. Chlorophyll-A is the predominant type of chlorophyll found in green plants and algae. Chlorophyll is a very important chemical that needed in our oceans. This presentation covers chlorophyll in the near polar zones, such as the Imminger Array, as I said before, the Station Papa Array, and the Southern Ocean Array, as well as a few other topics surrounding the chemicals that are important into our ocean and what they need to survive. Methods for chlorophyll-A at the near polar zones and similar data. Methods: the Imminger Array in the North Atlantic Ocean, which is up here. The Station Papa Array, which shows over here in the top left-hand corner. The bottom one that is highlighted is the Southern Ocean Array in the South Pacific Ocean. It is also known as the near polar zones, which are, as I stated, highlighted in figure 2. The Imminger Array is located off the coast of Greenland. The Station Papa Array is located off the Gulf of Alaska, and the Southern Ocean Array is located on the west of the southern tip of Chile. There are several tools in these areas that measure different things in our oceans so that we can continually monitor our oceans and how it is either progressing or declining in certain situations. Some of the data they collect in these areas are the temperature, the salinity, the dissolved oxygen, the nitrate, and many more different things. As for the results, in this figure up at the top left-hand corner here, this is for the chlorophyll and how they monitored it in between 2015 and 2016. Um, the chlorophyll concentrations change all year round in the North Atlantic, North Pacific, and the South Pacific, as shown in the graph above. Between April and July, in the North Atlantic changes drastically. If you see here in the blue, it goes up and then it plummets shortly around July. After that point, it seems to steadily go up and down. Eventually, stays around zero around December to January, all the way until around April again the following year. When looking at the graph, you see during certain times of the year, it will go up with temperature and then drop as the temperature goes down. This alone can predict what the next several years may be like for the chlorophyll alone. When looking at several different graphs and water properties on our ocean, we can see what affects which chemical and what helps it flourish. If you look at the green, which is the South Pacific, versus the blue, which is the North Atlantic alone, shows that each area of the ocean will have different chemical properties, as well as temperature alone can make a huge difference. The South Pacific green stays around the same all year round. The yellow Pacific changes a little throughout the year, but not as drastically as the North Atlantic, which is the blue in the previous figure. The South Pacific array just stay above zero all year round. With that alone, the North Pacific also stays generally around that range, as well, but has more changes than the South Pacific between May and the end of April, is when the North Pacific has most of its changes. The North Atlantic has the most changes around April to August. After that, all three locations stay around 4 to 0. With primary production, this shows that with the temperature of the area and the time of the year, that area chlorophyll will either do well or dwindle. Chlorophyll prospers more when it's warmer and there's more sunlight to work with. There are many different patterns we can observe within these areas and the properties with monitoring our ocean. The chlorophyll alone prospers with warmer climates and is able to provide photosynthesis to the life within the oceans better at times. The polar zones themselves are typically colder climates for longer periods of time within the year. So those areas typically don't have much changes except for a short period within a few months of the year. Chlorophyll alone allows plants to photosynthesize, as I stated before, and are able to use the sun to turn simple molecules into organic compounds, or otherwise known as their food, to consume, since they do not eat like the most of us, like the rest of the population in the world. Temperature is something that affects many different chemicals and properties in many different locations and situations. For this specific topic, chlorophyll relies on the sun and the warmer temperature to survive. Primary productivity and geography rely on one another in several different areas and reasons. Primary productivity alone depends on photosynthetic capabilities, availability of nutrients, topsoil, or lack thereof, as well as the sun and precipitation, as well as many other things. Geography, for this matter, can depend on if it's the ocean or it's the land. Geography plays a big role, just as big role factor as the primary production does. Discussion and conclusion. Within these three photos here are the different locations of the arrays that are being covered in this presentation. Discussion and conclusion. The proximity to the shore can make a big difference in temperature of the water, let alone the chlorophyll. Chile can have typically be a warmer country during the summer, which is where the southern ocean array is closest to, though they do get colder weather there in their ocean where the array is located, typically colder than the land itself. Land, all in all, is warmer than water due to it is able to hold in more heat, um, more so than water alone. Questions I guess I would have is I still have is how often do these properties monitored and graphed out? Are there still scientists out there that typically graph them on a regular basis, or they do it every so many years just to kind of see how it differs? I also wonder how much of a big change has happened in the last 40 years, let alone the last 10, especially since many, many people talk about the polar caps melting. These would be the references. These photos, so this bottom left-hand photo is a photo of the algae within the ocean near the bottom of the ocean. The top right-hand corner photo is the temperatures, just a photo showing the different temperatures in the ocean, as well as the top left-hand corner shows the polar, the temperate, and the tropical for different things. And I hope you guys enjoyed my presentation. Thank you so much for listening. Have a